Satellite imagery has confirmed that China is constructing a nuclear-powered supercarrier, the Type 004, a vessel projected to outsize even America's USS Gerald R. Ford. This isn't a small technological step, but a leap that could redefine modern maritime engineering. In this video, we'll explore how experts uncovered this project, what makes the Type 004 unique, and why it's drawing global attention. China's Type 004 represents one of the most ambitious engineering projects in modern shipbuilding. Satellite images from the Dalian shipyard show extensive construction activity. Large modular hull sections are positioned within newly reinforced dry docks, accompanied by cranes designed for heavy lift operations. These updates suggest a build optimized for rapid modular assembly, a process that significantly shortens production time and increases efficiency. Analysts estimate the ship's displacement between 110,000 and 120,000 tons, exceeding the U.S. Gerald R. Ford class by at least 10%. The vessel is expected to measure roughly 320 to 330 meters in length and accommodate a crew of about 5,000. Powering such a giant requires a completely new energy approach. The ship's twin nuclear reactors are believed to be adapted from the same technology used in China's latest nuclear submarines. This transition to nuclear propulsion grants the carrier virtually unlimited operational range and enough onboard energy to sustain advanced electronic systems. One of its most significant innovations is the EMALS, electromagnetic aircraft launch system. Unlike older steam catapults, EMALS uses electromagnetic force to accelerate aircraft smoothly, reducing mechanical strain and increasing launch frequency. Experts predict the Type 004 may feature 4 or even 5 EMALS catapults, allowing simultaneous operations and greater sortie rates than any previous carrier. Its vast flight deck could host 90 or more aircraft, including stealth fighters, airborne early warning planes, and advanced drones. China's ongoing work at the Wuhan Carrier Test Facility further supports this design evolution. Engineers are reportedly reconfiguring the mock deck to replicate the Type 004's launch layout, suggesting that ground testing for EMALS and deck coordination is already well underway. Combined with the Dalian shipyard's modular strategy, these developments indicate synchronized progress between design, manufacturing, and testing teams. The Type 004 is the product of a deliberate, multi-decade progression that transformed China from a carrier newcomer into a leader in maritime design. It began with Liaoning Type 001, a refurbished Soviet-built hull that introduced China to carrier aviation. Though limited by its ski jump ramp and lack of catapults, Liaoning served a critical role, training pilots, testing deck procedures, and building operational know-how from scratch. Its value wasn't in combat readiness, but in education, a floating classroom for a generation of naval aviators and engineers. The second step came with Shandong, Type 002, the first carrier built entirely in China. Shandong was larger, sturdier, and more comfortable for long deployments, marking a leap in industrial competence. It validated the nation's ability to design, assemble, and launch complex warships domestically, proving that its shipyards could handle large-scale production with precision and efficiency unmatched in the region. Then came the transformative Fujian, Type 003, the first Chinese carrier equipped with electromagnetic catapults and a flat deck. Fujian bridged the gap between experimental capability and operational modernity, demonstrating that China could transition from conventional carrier technology to cutting-edge systems developed entirely in-house. Each vessel added a layer of expertise. Liaoning provided pilot training and deck coordination. Shandong refined construction and logistics. Fujian validated EMALS and flat deck operations. These incremental achievements created a foundation of reliability and confidence. Now, the Type 004 builds upon all those milestones with nuclear propulsion and full integration of next-generation systems. Its modular construction stems from lessons learned during Fujian's assembly. Its reactor lineage traces back to submarine research, ensuring proven safety and performance. Even its anticipated crew structure benefits from years of accumulated training data, real-time simulations, and advanced coordination protocols across multiple carrier groups. China's approach has been strategic and systematic, introducing one major innovation per generation rather than attempting everything at once. This pattern minimized risk while accelerating technological maturity. Type 004 is not an isolated breakthrough, but the culmination of decades of refinement, methodically pushing the limits of design, power generation, and sea endurance. The construction of the Type 004 carries implications that extend far beyond shipbuilding. A nuclear-powered carrier provides sustained endurance, allowing operations thousands of kilometers from home bases. This capability transforms how a nation can maintain presence on the world's oceans, not through numerical superiority, but through technological self-reliance and efficiency. The ship's capacity for 90 or more aircraft gives it immense operational flexibility. With electromagnetic catapults, it can launch heavier, fuel-rich aircraft that can fly longer distances or carry more sensors and payloads. The likely inclusion of stealth fighters and early warning aircraft enhances the carrier's ability to coordinate complex missions, detect distant targets, and support unmanned aerial systems. It's not just about flight power, it's about real-time awareness across vast maritime regions. However, such progress introduces formidable challenges. Designing a nuclear reactor for a surface ship involves ensuring redundant safety systems, cooling mechanisms, and radiation shielding, all compactly fitted within a floating structure. Every subsystem must be tested for durability against sea motion, salt corrosion, and long operational cycles. EMALS technology, while revolutionary, is demanding. Maintaining consistent performance under continuous strain requires high-precision power regulation and robust maintenance practices. Crew training and technical integration will also be crucial. A ship of this magnitude is a floating ecosystem that demands highly synchronized teams, from reactor engineers and aviation specialists to communication officers and maintenance technicians. Establishing that human infrastructure will take years of simulation, testing, and live training. The educational infrastructure supporting this effort, specialized academies, digital simulators, and engineering partnerships, is already expanding to cultivate the next generation of carrier experts capable of managing such sophisticated systems. Financially, the scale of this project is unprecedented. Nuclear propulsion, EMALS, and advanced materials carry significant cost implications, but China's use of modular construction may offset much of the time and expense. The design's flexibility also allows for future upgrades, making Type 004 a long-term investment rather than a one-time project. Once operational, this carrier could serve not only in strategic missions, but also in disaster relief, research expeditions, and international collaborations. Its advanced systems enable aerial logistics, communications, and environmental monitoring on a global scale. In broader terms, the Type 004 signals a redefinition of technological competition, one focused on sustainable propulsion, electronic integration, and long-range capability. The Type 004 Supercarrier is more than a vessel. It's a milestone in the history of modern engineering. Its nuclear propulsion, electromagnetic catapults, and modular design make it a symbol of precision, endurance, and innovation. Each step that led to this moment, from Liaoning to Fujian, represents a steady climb toward mastery of technologies once considered out of reach. If completed as envisioned, Type 004 could become the most advanced carrier ever built, redefining what nations consider possible on the open sea. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.